Hi, I'll present to you the bike usage analysis that was done in the context of the Coursera course. And so we are analyzing the company Bixby, which is located in Montreal. And so that is a company that provides bike to users. And we want to know if we can distinguish the bike usage per membership status. This is an interesting question because it's directly related to the pricing per usage, and therefore it's related to the revenue for the company. It's something that will lead us to ask who uses the service most, and when we answer that question, the company can make choices, for example, apply promotions or discounts to encourage users to use the system more often. So we want to look at the pattern of usage for members versus non-members. If we look at the raw data, it doesn't speak to us. We don't see clearly a pattern, who is a member and non-members. This is a graph that represents the number of rides per day for a 2-month period. We need to better understand the data. And for that, we need to sort it. Once sorted, this is the data exploration, we were able to look at the trend of usage in one day. So the graphs that are presented here are for 2 separate months. So clearly, just by looking at the months, we know that April was less busy than May, and that members tend to use the bike system at more regular hours. So they are a lot of members using the bike system around the hours of 8 o'clock in the morning and 4 p.m., 4 or 5 p.m. in the afternoon. Whereas for non-members, they will tend to use the bike system mostly in the afternoon hours. Something else that's interesting that we can see by sorting out the data is the trend in ride duration per hour. So the members are very predictable. They use their bikes for shorter periods of time, whereas the non-members tend to use their bikes for a longer period at a time. And so usage characteristics that we can study for members and non-members are, for example, the distance of the trips, how long was that trip, and at what time of the day was it started. Also interesting is to look at the data per day of the week, and so we could possibly find differences depending on the day, and also depending on the week of the year. And what we have found is that we can detect members versus non-members based on their pattern of usage. When we use the machine learning approach, initially we used the k-means algorithm, and we had very poor accuracy results. Then we studied the gradient boosted tree, and we obtained a classification rate of 83%. When we turned to deep learning, surprisingly, the accuracy stayed the same. And so probably we could still improve the models to get better accuracy if that was possible. But I would recommend looking at the data in other ways as well. So looking at the number of trips done for each day. And this is a prediction of the long-term usage and in the future. And to do that, we will use deep learning approach, and more specifically LSTM. This is a graph, just an example, of the number of trips depending on the hour of the day and the day of the week. And now for my data scientist coworkers, this is the architectural choices that were made. So Big C has their open data available online at the following website, and there are zip files available on the website, and each one contains the following: a series of usage files, so one usage file per month. The file is in CSV format, and the trips are recorded per timestamp. Also, there is one CSV file that contains the station list for that year. The content of the files are the following. For the usage file, we had the start date, the location where they started is given by the start station code, when the trip ended and at what station, and also how long the trip lasted. Also provided is if it was a member or a non-member that stayed the trip. The stations list is a separate file and contains the code of the station, the name of the station, and the geographical location given by the latitude and the longitude. We decided to use the IBM Cloud platform and develop Jupyter Notebook for the analysis. We used the Spark 2.3 and Python 3.5. This is for parallelization. Excuse me. And we also used various toolbox, for example, the zip file for the import of the CSV file. In the case of the machine learning approach, we used the Spark CSV reader, and the data was in the PySpark data frame. As for the deep learning approach, when we were developing the deep learning approach, we encountered some limitation in the technology. And so the PySpark data frame did not work out, and we chose to move forward with Panda data frame. However, it's highly recommended that we go and make the PySpark option work in the deep learning notebook. We did the data exploration that was mostly presented in the prior presentation. We extracted, transferred, and loaded the data, and we did use Parquet files for accessing the data in the different notebooks. And we also performed feature engineering. We concatenated the monthly usage data under one variable. So for each month was from a different file, and we put that in one unique variable. We removed outliers and null values. We also concatenated the station list with the usage list, and it was easier that way to calculate the travel distance. And we transformed the timestamps columns into formats that were more easy to work with the learning algorithms. So week of year, month, etc. And we calculated the distance of each trip. So for the classification, the features that were selected were the distance, the duration of the trip, also at what time did the trip start, the weekday number, and as well the week number for the year. We used principal component analysis for dimensionality reduction, and we removed some features. For example, we had initially calculated the speed, but it's highly redundant with the distance and the duration of the trip, so that was removed. Also, the station codes were removed, and the timestamps column, for example. And those were the results that we obtained. So 20% with k-mean, 83% classification with the gradient boosted tree, and that stayed the same with the deep learning approach. What we performed was supervised learning. We know the classification, we know the expected values. And so in the future, what would be interesting is trying to predict the number of trips in the future per day, per hour, and also detect if it's a member or a non-member that has a higher chance of using the bike at that time. So there's still a lot of work to be done, but we got interesting classification results. This is an example of the deep learning approach of the model that was trained. We used three different sets of layers, and it was the dense layer with the sequential models from the Coursera. And as I was saying, this is the next step, is to analyze the number of trips per day and per hour of the day, and try to predict if it's the user is a member or a non-member. That could be very well interesting.